Hello. In this series of videos, I'm going to present how to build a simulation model using Excel for a very basic case to illustrate how Excel can be used for precisely those very simple cases. It's a case related to a coal depot. Exactly what we have is a depot here where we have some coal stored so that we can meet our demand. Some trucks arrive to our system to withdraw coal, and we have a coal mine, from which we obtain new coal, which is shipped using trains. As to the demand, we have a daily demand, which varies in quantity. So we have to satisfy some amount of demand every day, but that can vary. We'll see how in a minute. And when we do not have enough on-hand inventory here, we have stock out. So that first, the total demand we have each day is today's demand plus the previous stock out. So we don't lose our demand, we only postpone it until we have enough on-hand inventory. And we can compute today's stock out as this formula here. So this is the total demand, as I said before, the one we had today plus the stock out from previous days minus the on-hand inventory. If there's a value is positive, we have stock out. If not, okay, we don't have stock out and we are able to satisfy our demand, and we still have some extra coal in our depot for tomorrow. As to the supply, when trains arrive to our system from the coal mine, they always have 500 tons, but the time in between trains change from day to day, so it's variable. So because depending on the extraction pace at the coal mine, it takes longer or a lower amount of time to be able to be in conditions to ship a train. And as to the costs, we have the holding cost, which is €2 per day and ton, and the stock out cost. So every day we have an unsatisfied demand of 1 ton, we have some sort of cost or penalty or whatever that is of €100. And as to the demand and our supply, we have some historical data. So referring to the demand, we have observed that 7 times out of the summation of all these times, okay, we have seen that the demand was 70. 10 times it was 80, 18 times it was 90, 28 times it was 100 tons, and so on. Okay, so this is some record or some log about how many times we've seen each of these values in this very first row. As to the supply, remember, but the variability had to do with the inter-arrival time for trains. We saw that 5 times the next train arrived 2 days after the previous one. 13 times that value was 3. 17 times it was 4. 27 times it was 5, and so on. Okay, so this is how we have seen inter-arrival times in the past for the trains arriving to our depot. And we are going to make an assumption, and I'll discuss that a little bit later when I show the Excel file, is that trains arriving at day D, they do that, they arrive in time to satisfy the demand of day D. It's like the trains arrive, let's say, early in the morning, and the demand is known late in the afternoon or in the evening, so that when we arrive, when we receive the amount of 500 tons of this train one day, we can use that to satisfy the demand of that day, and we don't have to wait till next day to use it.